Today we are starting with the purification methods. This is the presentation of organic chemistry. This is a very short presentation which will give you little bit of idea about purification of compounds. What do we actually mean by purification, and what do we mean, and what are the methods by which a given compound can be purified from all other compounds. So in short, what should we know about purification? So to purify a given compound, why we actually need purification? First of all, the question arises. The question is itself an answer, because when you separate a particular compound from all other compounds which are which we do not want, so these are called interfering compounds, and we should have to remove these interfering compounds from the main compound. And to uh, get our main compound, there are several techniques applied. So all these techniques come under this section, purification of organic compounds. So organic compounds are either isolated basically from natural or resources, or from reaction mixtures. These compounds are rarely pure and are usually contaminated with small amount of other similar compounds which are found to exist together or formed during the reaction. So what are the basic processes that are used for purification of organic compounds? So crystallization, sublimation, distillation, chromatography, and differential extraction, and qualitative analysis. And seventh is, in short, melting and boiling point are the main tools and techniques that are applied to purify given compounds. Basically, crystallization is a compound to prepare the crystals of a given sample of our desired organic compound in basically crystallized form. So, to separate a solid compound in pure and geometrical form, we have to go by this crystallization method. So in this process, first of all, we have to choose our solvent, that the solvent should we have to use, and what is the preparation of solution, and what is and what are the techniques employed to filtration of solution, and then separating the crystals from other undesirable materials, and then drying of the crystals. And if the crystals are not properly formed, then we have to seed the solution even. So what is this, and what how do we apply them, and how do we perform them, comes under this crystallization process. Crystallization of phthalic acid. First is fractional crystallization. So what do we actually mean by fractional crystallization? It is a method of refining substances based on differences in solubility. It fractionates, that is, via differences in crystallization, forming crystals. When there is a mixture of solids differing in their solubility in the solvent, each component of mixture can be separated in pure form by fractional crystallization. From the mixture of solvents in the solvent during cooling, less soluble component crystallizes first, because that is insoluble, leaving behind other component which is more soluble. Thus, one by one, different compounds are isolated. Further, individual compounds are purified by recrystallization. This is the fractional crystallization schematic diagram. You can see this is another diagram. Second is sublimation. Sublimation is the process in which a solid is converted into vapor. Any substance in its solid form has to be converted into vapor in this process. To separate volatile solids specifically, we have to apply this process, which passes directly into vapor state on heating from a non-volatile solid. So principle is, a mixture of solid substances such as camphor, benzoic acid, ammonium chloride, iodine containing non-volatile substances, when heated, change directly into vapor without passing through the liquid state. So we don't have to really concentrate on the liquid state, so that we have to surpass this state by coming directly from solid to gaseous state. So this is the process. We have to heat the mixture, and this is the asbestos sheet, and this is the funnel, and we have to apply the cotton plug to get the substances, the vapors of substances which have to be purified. Distillation is the third process. Distillation is basically the vaporization. To separate a solution of a solid in a liquid, and for separating a solution of the liquids whose boiling point are different. Principle is, basically, distillation involves the conversion of a liquid into its vapors above heating, and then cooling the vapors back into the liquid depending on the difference in boiling point of liquids. There are basically four types of distillation processes, that is simple, fractional distillation, and distillation under reduced pressure, or that is vacuum distillation, and their fourth process is steam distillation. Simple distillation is the used for separating liquids having boiling point differing by just 10 to 20 degrees. Liquid having the lower boiling point distills over first, and the other liquid component is left behind. In this process, vaporization and condensation occur side by side. For example, like cyclohexane and toluene mixture separation. Then fractional distillation. Fractional distillation is basically performed by the use of fractionating columns. A simple fractionating column is, you can see from here, this is the simplest fractionating column. So what is the process? The mixture of liquids taken in distillation flask fitted with thermometer and condenser is heated. A liquid having lower boiling point boils out first, and its vapors are condensed and collected till there is no rise in temperature. When boiling of more volatile solid, more volatile liquid stops, another liquid starts boiling at its boiling point and can be collected in the pure form separately. Another process is distillation under reduced pressure. The pressure of the pressure of the liquid have to be reduced so that its boiling point also get reduced. This is the main principle. The lowering of pressure on the surface of liquid lowers the boiling point. As a result, a liquid can be boiled and distilled without any decomposition at temperature much below its normal boiling point. Actually, these process specifically can be applied on those liquids which usually decompose at its boiling point. So to prevent their decomposition, we have to reduce the pressure over that liquid, so that liquid has to be boiled at a much lower pressure than usual, and then the decomposition of that particular substance can be prevented. So this is the main idea, this is the main process, this is the main key concept behind this process. Then there is distillation and reduced pressure in this diagram. You can see this is the diagram in which there is a manometer. Manometer is basically a device used to measure the pressure. It is a very specific device. It measures the pressure in millimeter mercury. Distillation under reduced pressure, it has schematic diagram given here. This is the diagram that is directly taken from NCERT. So if you have go through that book, you can find that there is another diagram presented here. Distillation under reduced pressure. We have some liquids decompose during heating even before the boiling point. For such liquids, distillation and reduced pressure is carried out. When external pressure is reduced, the liquid boils at a lower temperature than its boiling point. So this process is basically performed on glycerol, recovery of glycerol, because the recovery of glycerol is the main thing, because glycerol is a very useful and important liquid used in various industries, various chemical industries and various industries throughout the world. So it is a main liquid, and so we have to separate it from other other impurities. So to separate it from other impurities, we have to apply this process. So this is most important process in fact. Even another process is sugar industry. Cane juice is concentrated by days process. इस प्रोसेस से भी हम शुगर इंडस्ट्री में केन शुगर को बना सकते हैं, वैक्यूम डिस्टिलेशन हम कराते हैं. Then there is another process known as steam distillation. This technique is used for separating purifying liquids which are otherwise immiscible with water, volatile in steam, and have vapor pressure at the boiling point of a mixture. There are various mixtures like citral compounds like aniline, phenol. Process is some liquids having boiling point much higher than the water but boils at lower temperature. When steam is passed, these liquids are usually insoluble or soluble in water. This type of liquids are called steam volatile liquids. In this liquid is heating on wire gauze, during which steam is passed through the liquid. Liquid vaporizes and comes out along with water vapor, and then mixture is condensed. Those which are non-volatile are left on the flask. Organic liquid is separated by extraction using solvents like ether by separating funnel. This is the schematic diagram presented here. You can see this diagram. Applications of all these processes are, from this method, aniline can be purified. Aniline can be purified by this steam distillation. Second is from plant extract also. From plant extract also, we can purify lemongrass oil and eucalyptus oil. These are essential oils that we have to purify. So from various plant extract, we can purify these by this process. Chromatography. Chromatography is yet another method. Chromatography is yet another method which is useful and which is very important and which is a little bit easier and more favorable from by all these methods. Chromos basically means color and graphy means a pattern. Graphy means a pattern. So it is basically a pattern of colors. So by this colorization or by the finding or by analyzing the pattern of these colors, we have to actually identify a compound. Principle is basically the principle behind this technique is the differential adsorption of various component of a mixture between two different phases that are as follows: fixed or stationary phase, mobile or moving phase. Commonly employed chromatographic techniques are column paper and ascending and descending radial paper and thin layer chromatography papers. So these are basic processes. So one by one we go through all these processes. Column chromatography is shown here, in which a solvent is applied at the top and a mixture of compound is separated. Stationary phase, this is the adsorbent, and glass wool we have to apply the glass plug also, so that no liquid gets poured out from this layer. Then there is a thin layer chromatography. This is basically in alumina in use, an alumina coating on the flat glass strip. This is thin layer chromatography in its basic idea. Then there is a paper chromatography. This is also known as partition chromatography, because here we have to get use of the principle that is partition. Then paper chromatography. Then there is a differential extraction. Here the solubility of a particular solvent is measured, or solubility of a particular solvent is observed in a particular solvent, because it is the kind of method that you basically depends upon the solubility of a given solvent in a particular given solute in a particular solvent. If a solute is more soluble in one solvent, then it will go into that solvent and removes and get away from another solvent, and hence we have to get our purified compound. This is the main principle: to extract a compound that is present in very small quantities in an aqueous solution with the help of an organic liquid in which that compound is highly soluble. So these all were the main techniques, important techniques that we should rely upon to get our compound purified. Thank you so much.